Dear student, welcome to my channel. Today we'll practice some more example from surface area and volumes. And today we'll start from question number 10. In question number 10, it is given a solid is in the shape of a cone standing on a hemisphere with both their radii being equal to 1 centimeter. And the height of the cone is equal to its radius. Find the volume of the solid in terms of pi. So we have to clarify that here it is written the answer should be in terms of pi. So according to the question, I have drawn the figure here. This is the hemispherical part and this is the conical part, and as it is given the radii being equal to 1 centimeter, it means that one is 1 centimeter, that height also 1 centimeter, that one mean the radius of the hemispherical part also 1 centimeter, and radius of the base of the conical part also 1 centimeter, and the height of the cone also 1 centimeter. Now we have to find the volume of the figure in terms of pi. So let us start. First we will find the conical part. So we will write the volume of conical part equal. So what is the volume of a cone? It is 1/3 pi r square h. So we'll write 1/3 pi, let it be, because as it is given in terms of pi, so we'll not change the pi. So 1/3 pi r square. So r is given 1, so here will be 1 square. Then height also given 1, so 1. So it is 1/3 pi r square h. This is the volume of conical part equal. If we simplify it, so here will be 1 square into 1 equal to 1. So it is pi by 3. Pi by 3 as it is given volume. So it is centimeter cube. Now we'll find the volume of hemispherical part. Hemispherical part equal. So hemispherical, so what is the volume of hemisphere? It is 2/3 pi r square pi r cube. So it is 2/3 pi r cube. So we'll write 2/3 pi r cube. So what is r? R is 1 centimeter. So we'll write into 1 cube equal, it is twice pi by 3, because 1 cube equal to 1. So it is 2 pi by 3 centimeter cube. Now to find the total volume, so we'll add it to get the answer. So we'll write now, therefore the volume of the solid, equal, first pi by 3 plus twice pi by 3. So right here 2 pi by 3 equal, taking LCM as 3, so here will be pi plus 2 pi equal 3 pi by 3. So 3 cancel, here will be pi centimeter cube. This is the answer. So I hope you can understand. Now we'll start question number 11. In question number 11, it is given that Russell, an engineering student, was asked to make a model shaped like a cylinder with cones attached at its two ends by using a thin aluminum sheet. The diameter of the model is 3 cm and its length is 12 cm. If each cone has a height of 2 cm, find the volume of air contained in the model that Russell made. So this is the question. According to the question, I have drawn the figure already. I have drawn it. So you can see here, this is the model and total height of the model. Total height of the model is 12 cm and the diameter is given 3 cm and the two cones which are having the height 2 cm and radius is equal to the radius of the model. So as the diameter is 3 cm, so radius will be 1.5. So during the calculation we'll use 1.5 cm as radius, and the cylindrical part, you see the height of the cylindrical part, we can get it from the total height. If we subtract these two heights, here also 2, here also 2 of the conical part, so it is total height is 4. So we can subtract this 4 cm from the 12 cm to get the height of the cylinder. Now we'll write the volume of the cylindrical part equal, so volume of the cylindrical part. What is the volume of the cylinder? It is pi r square h. So we'll write pi, directly we can put the value pi into r. R is 1.5, so we'll write 1.5 into 1.5 pi r square into, what is the height? We already find it, 8 cm. So we'll use 8. So this is the volume of the cylindrical part. Now here it is not divisible, so we can let it be like this. So later on we'll calculate it. The volume of the conical part, now we'll write conical part equal. So you can see here two identical cones are there at the two ends. So we'll multiply by 2. So what is the volume of a cone? It is 1 by 3 pi r square h. So we'll write 1 by 3 into 22 by 7 into 1.5 into 1.5 into h. So h is 2 centimeter. So it is 2. So this is the volume of the conical part. Now we'll add both of these to get the volume of the model. So we can write here, therefore the volume of the model equal. So we'll write here 22 by 7 into 1.5 into 1.5 into 8 plus, then here 2 into 1 by 3 into 22 by 7, 22 by 7 into 1.5 into 1.5 into 2. So this is, now one thing you see, we can calculate here separately also, but we can make it easy by taking the common. You can see here also 22 by 7, 1.5 also there, 1.5 here also 22 by 7, 1.5, 1.5. But here you see 2 to the 4 is there, but here it is 8. So we can take 4 as common. So 4 and mean that part we can take common. So let us take the common, 22 by 7 into 1.5 into 1.5 into, we'll take 4 because here 8 is there, so 4 to the 8, so we can take 4 common. Then what will be left here? Here only 2 will be there, plus then 2 to the 4 already we have taken common here, so here 1 by 3 is there, only 1 by 3, here only 1 by 3, and all the others already I have taken the common. Now let me calculate here. Equal 22 by 7, let us multiply it, so it is 15 into 15, it is 2.25, 225, and here 4 into 22 equal to 88, so we'll write 88. So it is 0.00891. So how many decimals are there? Here 2 decimal. So we'll put here decimal. So 198. We got here 198. So we'll write equal. Here it is 198 divide 7. Here it is 7 into, let us take 3. So here will be 6 plus 1 equal to 7. Now 7 cancel, and it is also divisible by 3, so it is 66. So as it is volume, so we'll write centimeter cube. So at last you will write the answer. You have to write the answer as the question is given the volume of the air contained, so we have to write hence, don't forget to write the answer, hence the volume of air contained equal to 66 cubic centimeter or centimeter cube. So this is the answer. So now we'll start question number 12. In question number 12, it is given that a gulab jamun contains sugar syrup up to about 30% of its volume. Find approximately how much syrup would be found in 45 gulab jamuns, each shaped like a cylinder with 2 hemispherical ends with length 5 cm and diameter 2.8 cm. So this is the figure of a gulab jamun as I have drawn it. As it is given the total length of the gulab jamun is 5 cm, it means from here up to this is 5 cm up to the end. So this is the total height of the gulab jamun. Also given the diameter is 2.8 cm, it means that one is 2.8 cm. So if diameter is 2.8 cm, so the radius is 1.4 cm, and also the radius of the hemispherical part also 1.4 cm, here also 1.4 cm. So this is the dimensions given. Now we'll find the amount of sugar syrup contained in this gulab jamun, as it is given 30% of its volume is contained by sugar syrup. Now we'll write the diameter of the gulab jamun. You can write full form. So I am writing in short, gulab jamun equal, it is 2.8 centimeter. Therefore, the radius of the gulab jamun equal to 1.4 centimeter, and the radius of the hemispherical part equal to 1.4 centimeter. Now here two different combinations of figures are there. One is hemispherical and another one cylindrical. So here written the radius of the hemispherical part is 1.4 centimeter, and we will write the height or length also we can write, the height of the cylindrical part equal. So total height is given 5 centimeter. Here the radius is 1.4. Here also radius is 1.4. So we'll subtract 2.8 centimeter from 5 centimeter to get that height of the cylindrical part. So 5 minus 2.8 equal to 2.2. So we will write directly here 2.2 centimeter, the height of the cylindrical part. Here you can write centimeter. Now we'll calculate all the dimensions. We already find it. We'll write here. You can write it like that: 5 minus 2.8 equal 2.2 centimeter. Now we'll write, therefore, first we will find the volume of one gulab jamun. Therefore, the volume of one gulab jamun equal. Let us write here. So, what will be the volume of one gulab jamun? We will write first the hemispherical part. So, hemispherical part, we can see here two hemispherical parts are there. So, together it is the volume of one sphere. So, we can write what is the volume of sphere. It is 4 by 3 pi r cube. So, we can write 4 by 3 into 22 by 7 into r is 1.4. So, here will be 1.4 into 1.4 into 1.4. This is only the hemispherical part, plus, let me write here plus. So, now cylindrical part. What is the volume of the cylindrical part? It is pi r square h. So, we will write 22 by 7 into r is 1.4. So, 1.4 into 1.4 into h is 2.2. So, this is the volume of one gulab jamun. So, if we calculate it, we can see here it is divisible. We can divide it. It is 0.2. Here also 7, and that one. Here it is 0.2. Is there any other divisible things? No, there is no any other divisible. We can just multiply. So, if we multiply it here it is 88, 14 into 14. I am now multiplying with calculator. You can do it manually. So, here 1.4 into 1.4, then 0.2, so into 0.2, So it gives me 0.392 into 88 into 88. So it is 34.496. So it is 34.496 divide, it is 3, divide 3 plus, now we'll multiply that one, 22, 1.4 into 0.2, 1.4 into 0.2 equal to that one into 2.2 into 2.2 equal 0.616 into 22 equal 13.552. So it is 13.552 equal. So we'll take LCM 3 and then here will be 34.496 plus 3 into that one. So into 3 equal to 40.656. So it is 40.656. Here point is there. Equal. Now let us add it. So it is plus 34.496, 34.496. It is 75.152. So it is 75.15152 divide 3. So this is the volume of 1 gulab jamun. Now as it is given 45 gulab jamun, then we'll write therefore the volume of 45 gulab jamun equal 45 into 75.152 divide 3. So it is divisible, it is 15. So if we multiply it by 15 into 15, it is 1127.28. It is 1127.28 centimeter cube. Now we will find the volume of sugar syrup. Hence we can write hence the volume of sugar syrup equal, as it is given 30%, so we'll write here 30 by 100 into 1127.28 equal, so 0 0 cancel, just we have to multiply it by 3. So it is into 3 equal 3381. It is 3381.84 divide 10 equal. So one decimal will shift here in the left side as it is dividing by 0. So we'll write here 338.1 up to 18. That one we can write centimeter cube. Here you can write approx. So this is the answer. This is the volume of the sugar syrup contained in 45 gulab jamun. So I hope you can understand. If there is any problem, you have to practice it, then I think you can understand that one. Okay, now we'll start question number 13. In question number 13, it is given that a pen stand made of wood is in the shape of a cuboid with 4 conical depressions to hold pens. The dimensions of the cuboid are given 15 centimeter into 10 centimeter into 3.5 centimeter. The radius of each of the depression is 0.5 centimeter and the depth is 1.4 centimeter. This depth we can use as height. Find the volume of wood in the entire stand. So I have drawn a figure. You can understand, I hope. So these are the 4 conical depression and this is the pen stand. So here we have to hold the pen. Here we can hold the pen. So 4 depressions are there. Now how we can do it easily? First of all, we have to find the total volume of the stand. So as it is given, the dimensions also given. So 15 centimeter, it is the length, mean that one is 15 centimeter, 15 centimeter. Then breadth is 10 centimeter, means that one is 10 centimeter. And the height is 3.5, mean that one. So from here up to this is 3.5 centimeter. So this is the dimensions of the stand. We can find it first. The volume of the pen stand equal. So we will just multiply it 15 into 10 into 3.5. So it is 3.5 cubic centimeter equal. So it is 10 multiplied by 3.5. So we can just remove the decimal. So 35 into 15 we can multiply 35 into 15, 52. So it is 525 cubic centimeter. So this is the volume of the entire pen stand. Now we can write now the volume of each depression equal. So depression is conical shape. So you know what is the volume of the cone? The volume of the cone is 1 by 3 pi r square h. So we'll write here 1 by 3 into 22 by 7 into radius is given. Here it is. The radius of each of the depression is 0.5. So we'll write here 0.5 into 0.5 into height. So what is the height? This depth of the depression we can use as height. So it is 1.4. So this is the volume of each depression equal. So here it is not divisible, so we have to multiply it. Now I am multiplying with the mobile. So it is 0.5 into 0.5, 0.5 into 0.5 into 1.4 into 1.4 equal, and then into 22 into 22. So it is 7.7. So it is 7.7. We'll write 7.7 divide, it is 21. So it is 21. Oh, we can cut it 7 and that one. Yes. So it will be more easy. So better we cut it. Now 7 already cut. So just we multiplied here. Let me multiply again. So 0.5 into 0.5 equal into 0.2 into 0.2 into 22 into 22. It is 1.1. So equal to 1.1 by 3. So this is a centimeter. It is given in centimeter, so centimeter cube. Therefore, the volume of 4, as it is given 4 depression equal. So it is 4 into 1.1 by 3 equal 4.4 by 3 centimeter cube. Now we will find the volume of wood. Volume of wood. Therefore, the required volume of wood equal. So, what is the total volume? As we find it, 525. So 525, and to subtract this volume of the 4 depression, and it is 4.4 by 3. So it is 4.4 by 3. It is 4.4 by 3. Yes, it is 4.4 by 3. So let me take the LCM. So here will be 1575 minus 4.4 equal. So 1575 minus 4.4 equal 1570.6 divided by 3. So it is divisible. So it is divisible by 3. Let us divide it. So it is 3 5s are 15, 3 2s are 6, 3 3s are 9, and 16. So it is not divisible. It is not divisible by 3. So it is not divisible by 3. 1570.6. 1570.6 divide 3. So this is the answer. If we divide 3 equal to 523. So it is 523.53 centimeter cube. Approx will write, as it is not terminating decimal, so we can write approx. So this is the volume of the wood here used. So this is the answer, and today up to this. Next day we will start from question number 14. Thank you.